Hello friend, my name is SN Patil. In this video lecture, we discuss the equation of the sphere in a different form. This is the course EMTH 103A coordinate geometry. Okay, so let us start the definition of the sphere. Sphere is a locus of points moving in a space which are at fixed distance from fixed point. The fixed distance is called the radius of the sphere, and fixed point is called center of the sphere. So this is the fixed distance from P to C, and C is a fixed point, that is the center. Okay. Now discuss the different form of the sphere. The first we discuss the center radius form. Center and radius form. Okay, so here we use the distance formula. So first let P X Y Z be any point on the locus C in bracket A B C be the center of the sphere, okay, and small r be the radius. Okay. Now by distance formula from this figure, here we the distance from P to C we denote as a R. R is equal to under root. Now the point of P is known X, Y, Z, and the point of C A, B, C. Now apply the distance formula here. That is X minus A bracket square, Y minus B bracket square, Z minus C bracket square, plus Z minus C bracket square. Okay. Now the squaring both sides, then we get to take this term in right hand side, and the right hand side term take in a left hand side. That is X minus A bracket square, Y minus B bracket square, Z minus C bracket square is equal to R square. Okay, so this is the center and radius form. Now so let us discuss its particular case. If the center at origin, O, that is ABCR 0, okay, then the equation 1 become, say here, ABC right now 0, then X minus 0 is X and its square, so we get X square plus Y square plus Z square is equal to R square. Okay. So equation number, so equation 2 is called standard form of the equation of sphere. Now discuss the general form. See, suppose this is the second. Now the third, general form. General form. For general form, we take the help of equation 1. The equation 1 is x minus a bracket square plus y minus b bracket square z minus c bracket square is equal to r square. Now simplify this term. It can be written as x square. Now the expansion of x minus a bracket square. Okay, that is x square minus 2 times ax plus a square. Similarly for second is y minus b, that is y square minus 2 times by plus b square plus z square minus 2 times cz plus c square, okay, is equal to r square. Now it can be written as, first we write the second degree term, that is x square plus y square plus z square minus 2 times ax minus 2 times by minus 2 times cz. Now construct the only constant term, that is a square is here plus b square here and here c square, and put this right hand side constant term in the left hand side minus r square is equal to 0. Okay, now here we make the substitution. Put a is equal to minus u, b is equal to minus v, c is equal to minus w. Okay, and this constant term we write as a d, that is a square plus b square plus c square minus r square is equal to d. Say question number 1, 2, say question number 3. Okay, now put all these value in equation number 3, then we get the general form x square plus y square plus z square plus 2 times ux, 2 times vy, 2 times wz plus d is equal to 0. Now here in center radius form, the ABC are the center. Okay, so center is here, then center is minus u minus v. The center is ABC. Now the ABC is minus u minus v minus w minus u minus u minus v minus w. Okay, now radius. For radius, see here, the a square plus b square plus c square minus r square is equal to d. So find out here r. Okay, that is r is equal to plus minus the minus r square, put in right hand side, it become plus, and this d become minus, and the value of a, okay, the value here I'm simplifying this, that is the value of a is minus u square minus v square minus w square minus d is equal to r square. Now r square is equal to minus u square, it can be written as minus 1 square u square. Minus 1 square is plus 1, that is simply u square. So u square plus v square plus w square minus d, that is r is equal to plus minus u square plus v square plus w square minus t. Okay, now there are two values, and this is the distance, r is radius. Okay, so we consider the positive term, that is r is equal to under root u square plus v square plus w square minus d. Okay, so in general form, this is the center and this is the radius. Okay, now here some condition we can discuss on the u square plus v square plus w square. See, this is the square root term. Definitely, if this value u square plus v square plus w square is greater, okay, let us discuss some cases. If u square plus v square plus w square, if this value is greater than d, okay, then the center is minus u minus v minus w, no problem. Okay, and radius is what? Then radius is real. Okay. Now second, if u square plus v square plus w square, if this value is w, sorry, d, then d minus d is 0, then we get center, we get the sphere whose center is minus u minus v minus w, and the radius is, what will be the radius? Radius is 0. Okay. Now the third condition, if u square plus v square plus w square is less than d, then what happened? Then the equation, let us give its name is 4. Then the equation, general form equation, okay, this is the represent the sphere, and the radius is imaginary. Radius is imaginary. Okay, so these are the 3 cases in general form, remember. Now next is intercept form. 1, 2, 3. Now the next is, this is 1, 2. These are the cases. Now the fourth one is intercept. Intercept form. For intercept form, first we consider the general form. The equation 4 is a general form. Consider general form. Consider x square plus y square plus z square plus 2 times ux plus 2 times vy plus 2 times wz plus d is equal to 0. Okay. Now to determine the sphere, we require 4 conditions. Let us take the 4th condition as a sphere passing through the origin. Sphere, say equation number 5th. Okay. Sphere passing through origin. Okay. Origin, that is 0, 0, 0. Then what happened here? Then 0, 0 satisfy the equation number 5. Equation 5, that is put x is equal to 0, y is equal to 0, z is equal to 0. Then what we get here? So here only simply d is remaining. So we get d is equal to 0. Okay. So equation 5 becomes x square plus y square plus z square plus 2 times ux, 2 times vy, 2 times wz, okay, is equal to 0. Okay, so which is general equation of the sphere passing through the origin. General form passing through origin. Okay. Now since we discuss here intercept form, it means what? We find the equation of the sphere which cuts off intercept ABC from OX. एक मिनट, to find equation of sphere which cuts off intercept ABC from OX, OY, OZ axis. Okay. Now here, if it cuts off intercept A from X axis, okay, here if it cuts off intercept A from X axis A00. Okay, then this A00 satisfy the equation, new equation, general form of the passing through the origin, say equation number 6. Now put here in equation number 6, that is y0 z is 0. Then what is the remaining term? Here the value of x is a. X is a, that is a square plus 0. Y square is 0, z square is 0, x is a plus 2 times u a. Now y is 0, z is 0, last two terms are 0. So here we get the value of u, that is u is equal to, first we simplify, a square is equal to minus time 2ua. Okay, so here one divide throughout a, that is u is equal to 2 is divide minus a upon 2, see the value of the u is minus a upon 2 when it intercept x-axis at a. Similarly, the sphere cuts off intercept b from y-axis. Similarly, the sphere cuts off intercept b from y-axis and c from z-axis. Okay, then we get v is equal to minus b upon 2 and w is equal to minus c upon 2. Okay, now put this value, put in equation 6. So we get intercept form. We get x square plus y square plus z square minus ax See here, when we put the value of u here, minus a upon 2, 2 will get cancelled, minus plus sign become minus, okay, minus b upon y similarly here, and c b into y minus cz is equal to 0. So this is the required intercept. Okay, now next is diameter form. It is the fifth one, diameter form. For diameter, let us trace the diagram. This is the sphere. The point, first point say P. The second point is Q. The line is passing through the center of the sphere. That is the diameter. Okay, say C. And the point P whose coordinate is x1, y1, z1. And Q x2, y2, z2. And R be the any point on the sphere and connect the R with P and Q. So here there is a right angle is formed whose coordinate is x, y, z. Okay. Now from the figure, let P x1, y1, z1, Q x2, y2, z2 as a diameter. Okay. Let capital R be any point on the sphere. Point on the sphere. So here we use the direction ratios. See the direction ratios of PR, DRS of PR is equal to x minus x1, comma, y minus y1, z minus z1. Similarly, DRS of QR is equal to x minus x2, y minus y2. See here, x minus x2, y minus y2, z minus z2. Now, here the angle P R Q is 90 degree. Okay, that is PR is perpendicular. This PR is perpendicular to the QR. Okay. And we know the formula. The product of these direction ratios are 0. Okay, that is x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 is equal to 0. Okay, so this is required diameter form, which is required diameter form. Okay. So did you get this point? See, instead of that, if you consider the vector, suppose This is A vector, B vector. A vector having component A1, B1, C1. Okay. B vector having component A2, B2, C2. Then the cos theta is equal to A bar dot B bar divided by its magnitude, magnitude of A into magnitude of B. Okay. If the theta is 90 degree, then cos 90 is 0. Okay. Then A bar dot B bar is equal to 0. That is A bar dot B bar is nothing but A1 into A2 plus B1 into B2 plus C1 into C2 is equal to 0. Okay. Theta is 90 degree. So same technique is applied here. Only these are the DRS and these are the component. Okay, now the last is 4-point form. Here I am direct putting the 4-point form. The equation of the sphere passing through the 4 distinct points x1, y1, z1, comma x2, y2, z2, x3, y3, z3, and x4, comma y4, z4 is given by the determinant. Okay, so this is the 4-point form. Touching sphere, two sphere touch externally, two sphere touch externally if the distance between their center is equal to the sum of their radii. Double I. Okay. That is from the figure D is equal to R1 plus R2. In touching sphere, there are two types of touching sphere. A sphere touch externally and sphere touch internally. The second is internally. This is the sphere and this another sphere. This center A. This center of B of the second sphere. A point, B point. Okay. Now this is the difference. You consider this difference as a D. Okay. That is the radius of the A sphere. The radius of the center A center A of the sphere is R1, and the radius of the second sphere whose center is B is R2. The two sphere touch internally if the distance between their center is equal to the, so instead of some difference is there, equal to the difference of their radii. That is D is equal to the A sphere means center A sphere whose radius is R1 and B is small, that is R1 minus R2. Okay, so these are the points we discuss. The first is definition, then center radius form, standard form of the sphere, that is center at origin. When we simplify the center radius form, then we get the general form. The equation 4 is general form with center minus u minus v minus w and radius is under root u square v square under root u square plus v square plus w square minus d. Okay, these are the some cases. Real radius, zero radius, imaginary radius, it's depend on the addition. U square plus v square plus w square, okay, is greater than equal to or less to d. Intercept form is x square plus y square plus z square minus ax minus by minus cz. Diameter form, that is x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 is equal to 0. Then 4-point form, and the last is touching sphere externally and internally. Okay, let us take the example on the center radius form. Find the equation of sphere whose center is -3, 1, 4 and radius is 5. Okay, now center is here and radius is here. So we use here center radius form. Now here let center of the sphere is given is equal to, this is RES, -3, 1, 4 and radius R is equal to 5. By center radius form, x minus a bracket square, y minus b bracket square, z minus c bracket square is equal to r square. Now here a, b, c are the, a is -3, b is +1 and c is 4 and r is 5. Substitute here, that is x minus, and here -3, minus minus plus, y minus 1, z minus 4 bracket square is equal to r square, that is r is 5. Now simplify a plus b bracket square, x square plus 6x plus 9, y square minus 2 times y, okay, plus 1, z square minus 8z plus 16 is equal to 25. Now first we write the higher degree term, x square plus y square plus z square. Then we construct the single degree term, x, y, z, 6x minus 2y minus 8z. Okay, now construct the constant term. Now here plus 9 and plus 16, that is 25. And in right hand side 25, 25 is cancelled. And only 1 is remaining here, is equal to 0. So this is the required equation of the sphere. Okay, now next, find the center and radius of the sphere. Now we have the equation of sphere, and from that equation of sphere we identify center and radius. Okay, so for that first we write the general form. The general form of the sphere, general form is x square plus y square plus z square plus 2 times ux, 2 times vy, 2 times wz plus d is equal to 0. Okay. Now here, the given problem, we write given problem as in the form of general form. See, 2 is there throughout. 2 is coefficient of x square, y square, and z square. So first we divide throughout 2. Okay. Now we have the given equation 2x square plus 2y square plus 2z square minus x plus 3y minus 5z, and we want the right hand side is 0, so that take 10 in left hand side, minus 10 is equal to 0. In general form, the coefficient of x square, y square, z square 1. So here remove this 2 so that we get the 1. So divide throughout 2, that is x square plus y square plus z square, okay, minus x upon 2 plus 3 upon 2 minus 5 upon 2 minus 5 is equal to 0. So equation 1 and equation 2. Now equate equation 1 and 2 and identify the value of u. Okay, so here the coefficient of x is 2 times u, and here coefficient of x is minus 1 by 2. That is 2u is equal to minus 1 by 2. We get the value of u. Value of u is 2 is divided here, minus 1 by 4. Now next, the coefficient of y is 2v, and here coefficient of y is 3 by 2. We get v is equal to 2 is divided here, 3 by 4. Now the coefficient of z, 2 times w, and the coefficient of z is minus 5. So the coefficient of z is minus 5 by 2. W is equal to minus 5 upon 4. Now the equate the constant term. D is equal to minus 5. Okay. Now here center of the sphere, we find out the UVW, that is center is equal to minus U minus V minus W. Substitute the value of U. U is minus 1 by 4, and here minus sign, 1 by 4 minus 3 by 4, and W is minus, and here minus sign. So here we get plus 5 by 4. Okay, now last radius. Radius of sphere in a general form is under root u square v square w square minus d. Okay, so is equal to the value of the u is minus 1 by 4 its square, 3 by 4 its square, value of the w its square minus d. The value of the d is minus 5. Now here 1 by 16 plus 9 upon 16 plus 25 upon 16, and here minus minus plus. Okay, so throughout LCM is 16. Okay, LCM is 16. So how we get LCM? Multiply and divide here 16. We get here throughout 16, and here 1 plus 9 plus 25 plus, so here 16 is multiplied, that is 80. Now here in denominator, the square root of 16 is exists. You can write simply 4. Now here this is the 10. 9 plus 1 is 10, that is 90. 90 and 25, that is 115, which is required radius of the sphere, and these are the set. Okay, thank you.